All right. We are live with Andy Rhodes from Vibe Cloud Reliability Solutions and Evan Zabowski from TestOil and myself, Heather Versilo with TestOil. Thank you everyone so much for joining us today. We are going to covering a variety of questions regarding lubrication and wireless vibration sensors. First, I'd like to introduce myself a little bit. My name's Heather, like I mentioned. I've been with TestOil for a little over 10 years now in a variety of roles. I'm currently in one of my favorite roles, though, as in charge of our marketing here, which has been great because I get to marry some of my technical experience with the creative side of life as well. And Andy, I'll let you go ahead and introduce yourself next.
Right, great, thanks. Yes, my name is Andy Rhodes, and I'm one of the founders of Vibe Cloud Reliability Solutions. We are a traditional predictive maintenance services company. We go on plants all over the world and provide condition monitoring services, analysis, vibration, the whole gamut. We work obviously with TestOil in the oil sampling and analysis area, which is a great joint venture we've been doing. And so we also have a wireless sensor that we introduced about 5 years ago, which is kind of at the very beginning of the whole wireless sensor craze. And we've been successfully deploying those for many years and have learned a lot of things about it. So,
all right, Evan, if you can introduce yourself real quick too.
Yeah, I'm Evan Zabowski. I'm the Senior Technical Advisor here at TestOil. And my role is mostly doing our training that is related to oil analysis, report interpretation, and even some certifications. Sometimes I also go on site and do audits or some consulting work, but this is my primary role is imparting knowledge like we're about to do today.
Exactly. So while we're talking about using wireless vibration sensors in your condition monitoring strategy, this is an open Q&A session. So for those of you that are watching online live right now, please feel free to ask your comments and the questions. Andy, Evan, and even myself a little bit, we'll be happy to answer anything that we can. If you happen to stump us, we'll make sure that you get an answer after the fact. But to get started here, because we only have 30 minutes together to keep this kind of like a lunch and learn, I did get some questions by email ahead of time. So I'm going to go ahead and start with a few of those for you both. So the first one I received was, how do wireless vibration sensors actually communicate with the internet?
Good. Well, that's a straightforward one, a 101 question. I like it. So there's a couple of different methods. I would say 95+% of wireless sensors on the market today communicate via a router, essentially like a Wi-Fi router has. They talk to the router, and then the router sends the information up to the internet in some cloud form like Amazon AWS or Microsoft Azure, one of these big cloud platforms where all the data can be processed and stored, and some AI is usually applied to it to figure out what's going on. So it goes to the internet essentially from the wireless sensor itself through a router, and then up via the router to the internet. And they do that for a lot of reasons. One is just because you can do a lot of pre-processing on that router, so you can minimize the data set, because it's all about how much data you send will impact how long the batteries last. That's how it's a big issue with the wireless sensors right now. Is
right.
How do I have to change them, how long the batteries last? And so that's essentially it. There are new sensors that are kind of cool. I don't think there's any officially on the market yet, but there's some R&D going around. Sensors directly communicating to the internet using like a cellular SIM card in each sensor. And it's pretty cool technology, but the power requirements are still high. So they're working on that.
Okay. So you mentioned this a little bit, but I did receive another question about what happens if we lose internet connection or we need monitoring in the basement of a plant that has absolutely terrible connection. I'm sure we've all been down there and you get no reception whatsoever. So what do you do in those types of instances?
Well, again, love these questions. So in the case where, well, the Faraday cage effect is the thing we all know, right? So if you put a wireless sensor inside a metal box around a gearbox or a motor or something that's completely enclosed, you're not going to get the signal out. It's just not possible. Mm-hmm. Now, what you can do is you can drill a hole and you can do some things. I've seen installations where they've added plexiglass and things like that, where you can get rid of some of the metal and then the wireless signal can get out. But if you don't have signal, say Wi-Fi, there's also old-fashioned Ethernet cables. So most routers on the market offer Wi-Fi and Ethernet cables and SIM cards for cellular. So those 3 ways you can get that data to the internet, even if you're in a place that doesn't get good Wi-Fi or cellular data, for example.
Okay, perfect. So I like this question a lot. I think it's something that we hear in a lot of different industries. But why should I buy a $500 sensor when I could buy a $200 sensor? What makes one better than the other?
Yes, thank you for asking that. I wish more of my customers ask that when they're looking at sensors, because there's so many sensors now. When we introduced our sensor, really it was about 2014. We had several plants running on our, I would say, prototype version, but 2015 we commercialized it, and our very first sensor was the only one on the market with a 10 kilohertz frequency, usable frequency range for velocity spectrums, and that's a whole bunch of vibration talk, meaning we had a lot more resolution. Think about the old camera phones where you can kind of see where the eyes are in a person. The resolution is so bad. And now the camera phones have the resolution that allows you to see everything, right? So it's a similar kind of thing that's happened with the technology. And in a nutshell, when you're spending $200 for a sensor, you're getting low resolution. When you're spending $500, you're getting high resolution. And what that resolution gives you is a longer view into the future. You can see more discrete frequencies. So, maybe you've got an electrical fault that's happening in a motor at 60 hertz, and you've got a gearbox fault at 59.5 hertz. And you're trying to watch those 2 amplitudes go up the spectrum over time independently, not as just one little clump. And if you don't have that resolution, that frequency capability, the wide frequency, then you're not going to be able to see it. And you're either your $200 sensor is going to detect it like within a day. Like you might be able to smell the bearing going out walking by at about the same time that $200 sensor goes off. But with the higher end sensors, you've got the 10 kilohertz. There's a couple that are higher, but 10 kilohertz is a pretty good top end for these sensors right now, and the price to the ROI. And on those, you're going to see stuff 3, 4, 5 months out, more like traditional walking route vibration analysis, where you can see a bearing slowly forming a little pit and it's getting a little worse. And you're like, well, it's 3, 4, 5 months out before we need to really change this. So that's the biggest difference between the little $200 sensors and the 500. Another is a lot of the low-end sensors maybe just work with a phone, and you got to walk by and you got to check things on your phone, where the higher end sensors will generally have a cloud infrastructure and an online website where you can see the spectrums. Some companies like ours, for example, will actually produce reports for you. So you can know exactly what's going on with a piece of machine, and you don't have to do any analysis yourself. You don't have to monitor any of it yourself. And so those are, again, some of the higher end features on some of the more expensive sensors out there.
Okay, perfect. Along the lines of data and seeing out months in advance versus a few days in advance, one question that I've actually received before, and you're going to be much better person to answer this, is, but they've asked, does vibration give too much data? And does too much data exist?
So that's, if you ask the AI guys, they'll say there's no such thing as too much data. The artificial intelligence guys have swarmed this space because, all the IT companies about 5, 6, 7 years ago went, oh, this is just an IT problem. We're just going to go and put AI in it. And that didn't work out too well. And every time I talk to those guys, because I do the trade shows and I've been to several of the AI conferences, and they're like, we just need more data, more data, more data. And I'm like, yeah, they say, look, we'll just run the machine to failure 100 times and then we'll know when the failure's about to happen. I'm like, you can't run a machine to failure 100 times. Are you crazy? Tell a maintenance manager they're going to run your machine to failure 100 times to learn so their AI can learn. Anyway, long story short is, I would say that, no, there's not too much data per se. The key is the quality of the data. Like I mentioned before, the high frequency, you want to have high data. You want to have high quality data so you can see a velocity spectrum, so you can see an acceleration spectrum, so you have enveloping and peak view so that you can see exact bearing frequencies as they start to spike. And so it's the quality of the data more than just too much data. And again, you need to be a qualified analyst to read the data. It's its own language, really, vibration analysis. And there's certification courses out there. And like, for example, our lab is full of level 2, level 3, and a level 4 to certified vibration analysts. And just to qualify to take the level 3 certification, you have to have been a vibration analyst for 5 years in the field before you can even take the qualification. So it's a
Okay.
pretty hard deal to be a really good vibration analyst. At least 5 years experience, and that to me is more important than just the raw data. Is how good are you at interpreting it? How good is the company that can interpret it for you?
Right. That's a good point. That's something that we talk about at TestOil too when it comes to oil analysis. And Evan's given webinars on that topic as well. I know he covers that in our training classes.
Good.
So this one, and they're asking about if you prefer a side exit or a top exit. If you're familiar with what they're referring to there.
Yeah, I think that's the configuration of the sensor, because the traditional walking route vibration sensors are either like a straight up and down sensor that you just, with the magnet on the end, and you put it on the motor. Like, let's say this is the motor, get in front of the camera, and you put the sensor down here. So that's a top exit. But some have a right angle on them. So they're called side exit. And with the wireless vibration sensors, it really doesn't apply, because it's really about just their size. And so there's some sensors that are big old, honking things you stick on a motor, some of the older ones. There's some of the new ones that are tiny, like 1 inch by 2 inches footprint. And so you can fit them in places. And that's really where that question probably comes from, is you got a tight space. How are you going to put the sensor between the motor and a guard, or, whatever it is you're trying to get that sensor in? So it doesn't really apply too much to the wireless sensors, but what is important is just their footprint, how big they are, their volume.
Okay.
Smaller is better.
Right. In this case, definitely. So one thing that we tend to see a lot, in a question that I've received, was companies will often perform just oil analysis. And how would you recommend that they start integrating vibration?
Well, whenever I get a new prospect that has that exact question, I always say that if you've got gearboxes and you have one thing to do oil analysis. I said, if you've got 2 things to do, add vibration. Because oil analysis, to me, and you guys obviously can speak more credibly on this, but is the number one thing, especially for gearboxes. Anywhere there's serious lubrication, it's the first technique you want to use. But when you add vibration, what's nice is now you have a 2-pronged attack. And there's some things that vibration isn't going to see that oil analysis is going to see, and vice versa. So take gear mesh frequencies. So let's say a gear tooth breaks, and vibration will see that pretty much right away. And oil may take a little bit of time. Number one, when's your next sample? Unless you've got an online system or something with oil, it may take a little longer. But if it's a slow evolution where maybe the teeth are starting to tear and starting to get some wear on them, oil will see that right away at about the same time as vibration. But what's nice is then you can kind of see how bad it is. So you can look at the oil test and go, wow, I got a high bunch of iron or whatever in this gearbox all of a sudden. And look at that, my vibration signal is looking bad too. Let's get this thing set up for maintenance right away. So they work so well together. They're a double check, and they also have some things the other one can't see. So
I'm going to I prepared this a little bit beforehand. Just when we were preparing for this session starting about a month ago, the 3 of us were talking about lure oil analysis versus vibration analysis and strengths. So I don't know if you guys want to talk on this a little bit more. Andy, you covered a lot quite there, but I just want to throw this up on the screen at least so people could get a quick view of a brief summary of the different strengths of each technology.
Yeah, this is a super handy chart.
I would add is, like you just said, that if you have a very slow wear mechanism, oil analysis could pick that up right away. And of course, it would eventually manifest itself into vibration analysis. And either technology could tell you that you have wear. But the bigger question always is that wear is often just a symptom, right? It's not the cause. The cause is, potentially a misalignment and imbalance and overloading, which vibration does very, very well at detecting those at the early stages. But things like contamination, incorrect viscosity, just outright wrong type of oil, all these kinds of things are detectable through oil analysis at its very early stages before the wear even happens. So, as an example, if you had a gearbox, which, normally are naturally vented to the atmosphere, they have no significant breathers, no filtration. If you see your particle count start increasing, you're like, hey, this looks like it's getting contaminated. And if it stays this contaminated, we will see wear. And then obviously, if we see wear, we'll start to see something in the vibration too. So that's the nice thing about having two technologies, is something like an imbalance. Your vibration reading would tell you that on the first rotation and say, yeah, this isn't right. Right. And you don't have to run it to the point where there's all this wear debris being created that suddenly everyone knows there's a problem. Like you're joking, you can smell the bearings kind of thing. Versus, yeah, if you just had like a lot of moisture content in your oil through, improper storage or whatever it might be, you'd know that on the very first oil sample. And again, you wouldn't have to wait for all that corrosion or wear to take place. It would eventually trip all the alarms.
Mm-hmm. Perfect. Thank you for going into more detail on that chart. And we do have a couple questions now coming in. So I'm going to grab this first one from Gary. So he's asking, are these permanent mounts or can you relocate them for non-critical equipment data capture?
So some wireless sensor systems are more geared towards moving them around, towards maybe monitoring one line for a month and then moving everything and monitoring another line for a month. I would say the majority of them are generally geared towards just putting the sensor on it, leaving it, done. Don't move it around. Because there's complexities in the back end when you move things. Like, we got to tell the database that it's not on this machine anymore, it's on this machine. All the trending now for that machine can't be associated with the sensor. There's just some technical, logistical issues with moving stuff around. As far as the actual mounting of the sensors, the preferred mounting is tap, because you want as strong a firm tension against the motor as possible for those high frequencies to work. There's a lot of documentation out there on even traditional vibration analysis where magnetic mounts can't really see past 5,000-6,000 hertz. So you've got to tap it in there to get the highest resolution possible, to get the best amplitude signal at those high frequencies. And but we also use adhesive. A lot of times you can't tap. I mean, a little thin motor cover or aluminum, or there's different reasons why you can't do that. Aluminum for the magnetic mount, but then you can also use magnets. Obviously, the stronger the magnets, the better. But all of those work. But as far as moving them around to just check out different machines like non-critical machines every once in a while, they can be used for that. But most systems aren't really geared towards that. There's a few that are specifically geared. They come in a little box and you just walk around the plant, you put them on there, but it's all localized. Nothing goes to the cloud. It's on a computer there. It's more for the on-site vibration analyst, but that's a useful tool.
Okay. And then along the same lines, so Wilson Van Loon, who we've worked with him for many, many years. So hi, Wilson. Thanks for joining us. But he was asking, are these not a triaxial setup? Yes,
most of them are triaxial now. When the first wireless sensors came out, a lot of them were single axis. But now they're triaxial, and they include temperature. And the temperature it's kind of a funny story on the temperature thing. When our first sensor came out, it was designed by our analysts. So our analysts were like, look, we don't need temperature. All we need is the highest frequency possible so we can do the best job possible in our work. And that's why our very first sensor was 10 kilohertz, because back then there was a lot of 1 kilohertz sensors and stuff like that. That was not great. Our analysts were like, we're not going to touch that. We're not going to be able to do our jobs with a 1 kilohertz sensor. But they didn't ask for temperature, because temperature is a lagging indicator. It comes after vibration sees things. But what's funny, the market said, hey, we want temperature. So now all the sensors basically come with temperature too, because it's a really inexpensive chip. And people like to see if the temperatures are going up. And once in a blue moon, once in 1,000 reports, that's roughly what I've seen. Temperature is the leading indicator. So I won't say it's all bad. But yeah, they're all triaxial now pretty much, and they have temperature as well.
Okay, perfect. So I'm going to go back to some of my email questions now. So one question I think people who are new to vibration have is they wonder what type of infrastructure is needed to begin using wireless vibration sensor. And they want to know, what do they need to tell their IT department?
Wow, these are some smart people out there, because these are all the best questions. So between you and me, your best bet to just get a wireless system up and running is to go with the cellular data on the routers. So most of these gateways will accept a SIM card in the router itself, and you can use AT&T or Verizon or whatever good cell signal you have around your plant Hopefully you have one. I know it's not always the best, but the reason that's the easiest and fastest way to get started is because then you don't have to tell the IT guys anything really. So, because as soon as you
Let's just
start
leave them
talking to
out.
IT guys,
That's what I try to do.
they slow down. They slow down hard. Especially, so sometimes your Wi-Fi, like a lot of plants are getting smart. A lot of the IT guys have already created IIoT wireless networks in their plants. And so if you've already got an IoT network, you're a step ahead because we can just jump on that with the Wi-Fi and the IT won't ask a question because they've isolated it. They've done all their IT stuff. So that's a clean network for IoT wireless devices. Otherwise, you know, the IT guys have 20, I've seen some 20-page forms we've had to fill out about our system before they'll even let us in the door. Some IT departments are,
Wow.
you know, security is important. But the key thing I always say is, and if you're starting to try the, you know, test the waters with wireless for your plant, is just say, look, and most systems are like this. For example, ours, there's no write capability. We can't write data into the plant. We can't send information into the plant. All we're doing is reading stuff. So it's literally a one-way connection, which most IT guys like, because if it's two-way, then they freak out because we can write into their plant somehow, right? But all we can do is read the information. And if some hacker hacks into everything, what they're going to be able to do is see the vibration levels on your equipment. And that's all. That's the only data they could ever have access to is the vibration levels on your equipment. I don't know what they can do with that, but that's it. So I tell folks, you got to just tell them it's a read only. And if they do get access, all they're going to see is squiggly lines about your machines. They don't even see the names of your machines. That's all just numbers, serial numbers. So,
Perfect.
So that's what I would tell your IT people, or just go cellular and let them, you know, sleep at night.
Just leave them out of it to begin with.
Yeah.
Perfect.
That's best for everybody usually.
Right, exactly. I agree with that. All right. So this question is for both of you. And this person wanted to know what types of lubricant issues can be detected by wireless vibration sensor versus oil analysis. And you guys got into this a little bit earlier on. So maybe let's try to go a little bit more in depth since this was a specific question.
Yeah, I think that chart really told the good story. I mean, that chart you had there, I think covered most of it. One thing I think about is, and I know that there's some grease analysis out there, but lubrication issues on bearings, vibration is really good for, to know if, you know, you don't have enough lubrication or too much grease, not enough grease, right? Vibration can help you with that. Yeah, this chart, again, I think really tells the whole, answers that question pretty well.
All right, perfect. That works for me. I just wanted to ensure that we covered that one. All right.
And I mean, really, one of the biggest things is even without, you know, even like, you know, vibration would say, yes, your bearing has enough grease, but a grease analysis, a lubricant analysis would tell you you had the correct grease. So there's things like that, you know, when you look at the differences, like, yeah, there are similarities. There are some things lubrication related, both technologies pick up. Question is when do they pick it up, right? If some can tell right away, some have to see some evidence of damage occurring from it. So, you know, oil analysis couldn't tell you if you had the right quantity of oil, nor could grease analysis tell you you had the right quantity of grease, right? Vibration stands out that way. It would tell you that, okay, this seems like there's an under lubrication, or especially in grease, there's an over lubrication. But oil analysis itself, fluid analysis would say it's the right one, it's the right additive chemistry, it has the right viscosity, you know, it doesn't have contamination, it hasn't degraded, you know, all these kinds of other issues that are very early warnings into a future failure. So, yeah, there are differences, but yeah, the chart does sum it up nicely.
Perfect. All right, it looks like we have a question from Hector, and he asked, is there a wireless system in the market that works like an online system?
Yes. There are some wireless systems that you can essentially leave the throttle open because most of them work where they can reading periodically. So there's a lot of confusion. Sometimes people say it's a continuous monitoring system. Wireless systems are not continuous monitoring. They're near continuous monitoring. So for example, like our system, you can dial it down to a reading a minute. Your battery might last a month if you do that though. So a lot of our customers do a reading a day and the battery lasts 3 or 4 years. which they prefer than going out to change batteries. So there are some, though, that you can dial all the way down to continuous, but it's going to eat battery. In that case, I would just get a continuous system. There, you know, if you really need continuous monitoring, I'd get a wired system, and because the wired systems have come down in price a lot over the last, say, 10 years. Because 10, what is it, 2012? Wow, 15 years. Oh, it's been a long time. 15 years ago, all you could do was wired systems, and they were very expensive. But like most things in technology, they've come down in price. And so if you really need continuous monitoring, like protection system, like for turbine or other really critical equipment, then I would recommend going wired, honestly.
Okay. Good to know. And let's see. I don't have any other questions that I was emailed ahead of time. And it looks like so far we've answered all the questions that we've had come through online. Gary just made a comment that he said he agrees with Evan in having the correct lubricant or grease has been a big issue for him in the past. Yeah. So it sounds like that's been an issue for many people, that just from my experience over time in general.
That's one of my favorite things about oil analysis, is just figuring out, are you really using the right stuff? I mean, that's like the number one thing. Like when we started an oil analysis program, with you guys for one of our customers, the first reports are all, this is all the wrong oil. You told us it's this oil, and this is what's actually in there. They're like, really? So that was the first month of, oh boy, what do we do? So it's right. An oil analysis is great, just really to take a look at your old program in general, not just the machines.
And when you talk to maintenance personnel or maintenance managers, they always say it couldn't happen, it shouldn't happen, and it wouldn't happen. Right. And I always say, you're not the only one here. There's night shift, there's weekend shift, there's operators who are doing it when they can't find a maintenance person to do it. I said, there's numerous reasons. I said, it happens. Trust me, it happens. It always happens. So,
it's always a big surprise.
Yeah.
That's very true. So we have just 1 minute left. So we did good on our time, guys. And I threw Andy and Evan's email addresses on the bottom. So if you have any questions that you think of later in the day, or you want to discuss something a little bit more, please feel free to email them at your convenience. There will be a recording of this session too that will get popped onto the TestOil YouTube page, so it will live in infamy forever there as well. And other than that, Evan and I have our next live Q&A. It's going to be September 27th at 12:30 Eastern. And we're going to be covering evaluating machine health at that point. So any questions you have on machine health and lubrication, or just lubrication in general, we're always happy to answer any questions. But otherwise, Andy, Evan, I want to thank you both so much for joining me, as well as everyone that came online today. And hope you guys have a great day, and enjoy the long weekend we have coming up too.
Right.
Thank you.
You too. Thank you.
All right. Great. Take care.
I appreciate it.
Bye.